decided to cover this topic of OSPF network types early on in the course, and the reason is when we are doing the labs and even in your real life examples, you will see different network types, and these different network types represent a network design or how things are interconnected in the campus network. So the first and the foremost network design that you will see is point-to-point network type. And the point-to-point network type refers to basically two routers connected directly to each other via serial link or frame relay subinterfaces. In this particular network type, there will be no DR-BDR process. I'll explain a little bit about BDR and DR process and the election process a little bit later in the course in more detail, but I'll cover some points here as well. Hello and dead intervals are used, and those are basically the default 10 and 40. Dynamic neighbor discovery, yes, dynamic neighbor discovery happens at point-to-point networks, because if you bring up two routers with OSPF protocol enabled, they will start communicating with each other right away. And only two routers participate in point-to-point network. More routers cannot be connected to this type of network. Two is the minimum or the maximum. Broadcast network. This is a very famous network, and this is the network in today's real world. Broadcast is basically an Ethernet network, meaning using a switch. In this network, there is a DR-BDR process. And let me explain the DR-BDR process. So if you have a switch and you have more than three routers, and those three routers will start communicating with each other through multicast. And in order to limit the number of the LSUs that are going and passing through the network, and to reduce that CPU utilization, OSPF starts by electing a designated router. The designated router receives the LSUs and starts sending the LSAs to all other routers. BDR becomes the backup designated router, and that election process happens through priority, to router ID priority, through a lot of selections that happen during the election process, and that we will cover later. The hello and dead intervals are the default. Dynamic neighboring, yes, it happens. Dynamic neighboring happens here as well. And yeah, you need more than two routers. Non-broadcast network, as it says, non-broadcast network also uses a DR-BDR process, and the hello intervals and the dead intervals are increased by 30/120. There is no dynamic neighbor discovery. Yes, you need two or more routers in this case. Non-broadcast networks, and the examples of non-broadcast networks are frame relay and ATM are the two main examples of this network. Point-to-multipoint broadcast network. In this point-to-multipoint broadcast network, there will be no DR-BDR process, and the hello and the dead intervals are 30/120. Dynamic neighboring can happen. It's a yes, and there is through multicast, and there will be more than two or three routers that will be participating in this. Actually, a lot more routers can participate in this, and one of the examples of point-to-multipoint broadcast network is hub and spoke topologies in DMVPN. I have a course on DMVPN if you are interested, but this is the typical network of DMVPN, and yeah, this is a very good topology and network, and you should know about it if you are advancing your career in DMVPN. Point-to-multipoint non-broadcast network is basically an extension by Cisco for this network, And basically it's all the same as point to multipoint broadcast, except this one is non-broadcast, right? So there's no BDR, DR process, there's no dynamic discovery that will happen here. But you can do that kind of a network and also use the DR BDR configuration statically on the network. So that means if you have a stronger router and you want to make that as your designated router, you should statically assign those configuration to that router and increase the priority of an interface and all that. We'll go into details later in our course on how to configure those priorities that I'm talking about. The last and the network type is the loopback address, for example, on the router. It's an interface that you basically assign an IP and you call it a loopback address. There will be no DR BDR selection here, and you can assign loopback addresses as much as you can, as many as you can. There will be no problem. And you will see the significance of loopback networks in most of the labs and in real world situations where you need an interface that is always up and running, and loopback is one of the interfaces that will always be up. And with that, I conclude this slide. I hope this was beneficial, and let's move on to our lab, which is point-to-point network configuration. Thank you very much.